Hello, this is Muhammad Usman, and today we are going to discuss the topic of sampling and sampling distributions. First of all, let us remind the concept of population and sample, which we have already discussed in detail. Population is the entire group under study, whereas the sample is the representative part of the population. Well, we have already discussed that. Uh, sampling unit is the actual study unit, and it may be plant, a group of plants, an animal, a student, a group of students, or a household, and complete list of all the sampling units. They are known as sampling frame, and sampling frame is necessary when you want to select a sample and a probability sample from your population. Okay, we'll discuss it later. Sampling. Sampling is then a procedure by which we draw a part from an overall population, and that part should be representative. So sampling is a complete procedure. We have already discussed the parameters and statistic. Parameter, they are fixed quantities, whereas statistic, they are variable quantities, and variable in a sense that they changes their value from sample to sample. So if the value is being changed from sample to sample, then there would be a distribution of it, and we will study it today. Sampling with and without replacement. Well, if we replace the first drawn unit to the population before drawing the next unit, the sampling is said to be with replacement, whereas if we did not replace the first unit back to the population before drawing the next one, the sampling is said to be without replacement. Well, there are broadly two types of samplings: probability sampling and non-probability sampling. Probability sampling is also known as random sampling, and there are further four types of it: simple random sampling, stratified random sampling, systematic random sampling, and cluster random sampling. Whereas the non-probability sampling techniques involves convenience sampling, judgmental sampling, quota sampling, and snowball sampling. Well, these are the renowned ones. We have others too. What is simple random sampling? Well, if a sampling units, they have equal chance of being included into the sample, then the sampling technique will be known as simple random sampling, and we will deal with it in future too as well. So let's move on to a simple example: an hypothetical population of three values, 2, 4, and 6, and a simple random sample of size 2 is to be selected. Technique that is with replacement, and your task is to find the population mean and variance, then draw all possible samples of size 2, all possible, with replacement, and then verify the properties of the sampling distribution of mean. Well, and there are two properties of sampling distribution of mean with replacement, and there are two that is without replacement. So in this question you will verify the properties of with replacement. Well, let's move on to the solution of this question. Because the sampling is with replacement here, so the total possible samples that could be drawn from this population, that is capital N raised to the power small n. So there are 9 samples. Let's start with the samples. These are the possible samples: 2 with 2, 2 with 4, 2 with 6, and then 4 with 2, 4 and 4, 4 and 6, and then 6 with 2, 6 and 4, and 6 and 6. Well, the next step is to take the arithmetic mean of all these samples. These are the means of all samples, and now your task is to take the mean of these means, which is 36 divided by 9, because the sum of the means here 36, and there are total 9 samples, so we will divide 36 by 9 and we will get 4. This we will call it mu of x bar. Similarly, we will take the variance of all these sample means, and that variance will be known as variance of x bar. And once we have done this, we will now move on to the population, and we will compute the simple mean and variance of the population. And once we compute the mean and variance of the population, now we can prove verify the properties of the sampling distribution of x bar. Now from the calculation in the previous slide, you can verify that mu of x bar is equal to mu, and this is true for all kind of population, for all kind of samples. Similarly, we can prove that the variance of x bar is equal to the ratio of the variance of population and the sample size. Wow, this is example 2, and we are supposed to do the same example, but this time without replacement. Wow. Let's move on to the solution of this example. Total possible samples, they without replacement, they are capital N combination small n. And they are 3C2, and the answer is 3, so there will be only 3 samples, and let's just see the samples. 2 with 4, 2 with 6, and then 4 with 6. It is without replacement, so no 2 unit will be repeated in our samples. Take the mean of these samples. The procedure is same. Mu of x bar is equal to this time 12 divided by 3, and that is 4. Similarly, we will take the variance of the x bar, and we have already computed the mean and variance of the population. That will stay same because the population is same in this case. Well, after calculating the mean and variance of the sum of all possible samples and mean and variance of the population, we'll move to the next slide and verify the properties. Well, from the previous slide, we can verify that mu of x bar again is equal to mu, that is 4 equals 4, and the sigma square of x bar is equal to the variance, population variance divided by the sample size and multiply by the factor that is known as n, capital N minus n over capital N minus 1. And the results, they are on your screen now. So these are the properties of the sampling distribution of x bar with and without replacement. Now, and these results could be extended to the differences between two means. Now suppose you have two populations and you draw samples of sizes of specified sizes from both the populations and then take the differences of those means. Well, if you do so, the properties, the sampling distribution of the difference between two means will be mu of x bar 1 minus x bar 2 will be equal to the mu 1 minus mu 2. And similarly, the variance of x bar 1 minus x bar 2 is equal to the ratio of the variance of first population divided by sample size 1 plus variance of the second population divided by sample size 2. And similarly, the without replacement properties. Thank you very much.